Hello everyone. I'm Andy from ThinkMo. I am currently teaching CCIE courses. From today on, I'm going to share with you CCNA, CCNP, CCIE related technologies. Our topic today is how to remember IP address categories quickly. We are basing this on 3 questions. To answer the question accordingly. The first one is, what is an IP address? The second IP address is divided into several categories. How is the third one classified? Just how fast do we do it? Remember IP address classification. First of all, what is an IP address? The IP address is called the Internet Protocol address. Internet Protocol address. So why have a protocol address? Because for network devices, it should have a corresponding identity service. An identifier acts as a locator. What do we mean by a locator? Let's say you have a house number. Which neighborhood does your family live in? How many units and building number is it? Or another simple example. Everyone has to have a name. So is your name Zhang Seiyan or Li Si? This is the IP address we're talking about. In the network environment, network devices must also have location services in the network. It's the idea of a name. So how many types of IP addresses are there? It falls into 5 categories: A, B, C, D, and E. So IP addresses, how are they classified? I've given you some notes ahead of time. Easy to explain. The first one involves base-based numbers. The IP address is in dotted decimal notation. To express, let's say we write an IP address 192.168.1.1. This is a common class C IP address. That's a 0 and a 1 in binary. 0 means no. 1 means there is. And the decimal number is 0 to 9. For IP address, it is expressed in dotted decimal notation. How many pieces does it have? It is divided into 4 sections. 192 is a segment and 168 is a segment. The .1 and .1 are 2 paragraphs. Each segment is represented as a binary number. A segment is 8 binary numbers. We also call it the 8 place, or 8 bits, decimal number representation. So that's what it looks like. Because it's in dotted decimal notation. That's going to involve about the conversion relationship between binary number and decimal number. We've probably all learned this before. It's okay if you forget. And the transformation relationship that we talked about today. It's not that complicated. Today we're talking about IPv4 addresses. IP address for short. Each segment of an IP address contains 8 bits. 8-bit. They also divide it into high and low. What does high mean? It goes from left to right and the leftmost one is the high one. The one on the right is the low position. It's the idea of going from high to low. That's in 8 bits. From high to low. Let's say it's 1. 1 means there is. The 8 bits first go from high to low. What is the actual number that it corresponds to? The value of each digit. Let's label it. The first one is 128. Second 64. The third 32. Fourth 16. Fifth 8. And then we have 4, 2, 1. So it's kind of like this. And then we figured it out. Contrast between binary and decimal numbers. Later you can remember the IP address classification. About the class address. You just have to remember the first byte. The first bit is always 0. So that means that out of these 8 bits, the first bit to the left of the high position, it's going to be equal to 0. So we can calculate that. When the first bit is 0, the remaining 7 bits are all 0. So what is the value? The value is 0. All zeros. All 8 bits are 0. It's all 0. When the remaining 7 bits. If they're both 1, that's the maximum. So its value is 127. Therefore, the class A address ranges from 0 to 127. This is the first byte. And then we have class B addresses. Here we add the concept of bytes. 1 byte is equal to 8 bits. The total length of an IP address is 32 bits. So this is equal to 4 bytes. The first 2 bits of the first byte of class B. Constant 10. So let's go back to the math. There are 6 bits left. 6 bits if all of them are 0. The value is 128. The remaining 6 bits are all 1. So that's 191. So class B addresses range from 128 to 191. The first 3 bits of the first byte of a class C address. That's the first 3 bits to the left of the top. Constant 110. So that means that these 3 guys can't change. So the remaining 5 bits. If both of them are 0. The value is 192. If the remaining 5 bits are all 1. So it's going to be 223. So it ranges from 192 to 223. The first byte of a class D address. The first 4 bits are always 1110. When the remaining 4 bits are all 0. It's going to be 224. When the remaining 4 bits are all 1. They add up to 239. This is the range of class D addresses. The first 4 bits of the first byte of a class E address. Always 1111 is good. So when everything else is 0. It's 240. When the remaining 4 bits are all 1. So it's 255. So the range of class E addresses. It's 240 minus 255. Class E addresses are reserved addresses. Mainly used for scientific research. We can't use it. Class D addresses are multicast addresses. Class A, Class B, Class C addresses. That's what we're using on the network right now. Of course, the network also includes public network and private network. We'll fill in the blanks later. That is to say, the Class A, B, C, that can be used. Class D is basically fixed multicast. This is the case with IP address classification. Therefore, the class A address is 0.0.0.0-127.255.255.254. Because 255 is the maximum. All ones add up to 255. Class B addresses are 128.0.0.0.191.255.255.255. Class C addresses are 192.0.0.0.223.255.255.255. Class D addresses are 224.0.0.0-239.255.255.255. And so on and so forth. Class E addresses are 240.0.0.0-255.255.255.255. About the above addresses inside. There are things that we'll talk about later, like private internet addresses. For example, the corresponding use of some special address. And we'll talk about that in a future video. That's it for today. If there are any other skills you'd like to learn, feel free to leave a message or send me a private message. If you're interested in what I'm talking about, hope to like and subscribe more. Thank you. See you next time.